This is Mrs. Wainwright's Math Class, Chapter 5, Lesson 8, Problem Solving, Decimal Operations, the Work Backwards Strategy. Today's learning target: by the end of the lesson, you should confidently be able to say, I can use the strategy work backward to solve multi-step decimal problems. The work backwards strategy has 3 steps, and we need to solve them in order and label them as we go. This strategy is only successful if we follow all 3 steps. The first step is labeled as SUS. The SU stands for setup, and the S in parentheses stands for solve whatever's in parentheses. So to do this step, the first thing we look for, which is in the question, is the unknown. What are they asking us for? We make a variable letter for the unknown, and we write that first. The next thing we do in the setup is find the total. What's the total amount that they're talking about? We put that at the very end after the equal sign. Once we start with the unknown and end with the total after the equal sign, everything else the problem tells us goes in between. So it's the unknown, and then everything else equals the total. When we have all of that written, we do the solve parentheses. So if what's in the parentheses can be solved and there isn't a variable or there isn't an unknown letter in there, we solve all of the parentheses. This is the SUS, the first step of work backwards: setup and solve parentheses. The next step is the work backward, the WB step. And work backward is exactly what it sounds like. We work backward, or we write the problem in the opposite direction, and anytime we go in the opposite direction, we use the opposite operation. Once we have the work backward written down, we move on to our third and final step, which is the S or solve step. And for the solve step, we will use some scrap paper, and we will solve the problem to find the unknown amount. Let's see how the 3 steps of work backward work in problem number 1. Example number 1 says Carson spent $15.99 for 2 books and 3 pens. The books cost $4.95 each, and the sales tax was $1.22. Carson also used a coupon for 50 cents off his purchase. If each pen had the same cost, how much did each pen cost? Well, this is going to be a work backward strategy because they give me lots of information and a total amount that I spent, and they're asking me for one specific part of that. First step, if I look at the bright blue, is my SUS step. So I'm going to write down SU and S in parentheses. SU is my setup. And look in the line right underneath the SUS step, it says unknown, everything else equals the total. How do I find the unknown? Go to the question. The actual question says, how much did each pen cost? So my unknown is the cost of the pen. I'll use the letter P to represent pen. Now I'm going to go back into the question and see if there's anything at all that they tell me about the pens. Carson spent $15.99 for 2 books and 3 pens. Oh, I see he bought 3 pens. So I have to say 3 times whatever a pen is, since he bought 3 pens. So I found my unknown variable, which was P. I'll cross that out. I know he got 3 pens. I'll cross that out since I used the 3. The next thing for the SUS step is to find the total. I have to look back at the problem and find the total amount that was spent. And it says Carson spent $15.99 for 2 books and 3 pens. So his total was $15.99. I leave lots of space because I don't know how long the problem will be. I go to the very end and write my total equals $15.99. I wrote the total, so I cross it out. Now I can go back and figure out everything else in between that unknown and the total. So if I go back into the problem, I see that books cost $4.95, and I see that he bought 2 books. So he had 3 pens, and, means plus, he had 2 books. Put parentheses 2 times, and they were $4.95 each. Let's cross out the $4.95 and the 2 books since I used that. What else do I know? Well, it says the sales tax was $1.22. And when you have sales tax at a store, are they giving you a discount, taking money off your bill, or are they adding money onto your bill? We all know, because we don't like sales tax, that they're adding money onto our bill. So sales tax is a plus. Therefore, I will write plus $1 $1.22, which is what he paid extra in sales tax. Cross that out since I've now used it. Carson also uses a coupon for 50 cents off his purchase. When you use a coupon, do you have to pay more money, which is adding, or do you pay less money, which is subtracting? Well, a coupon saves you money, so coupon, I'll put a minus right over the word coupon. So I'm going to minus $0.50 since we save money for our coupon, and I'll cross that out in my problem. So I have all parts of my SU, my setup. The last part of that is the S. I need to solve what's in parentheses. My first parentheses says 3 times P. I don't know what P is, so can I solve that? No. I can only solve parentheses where I know what all of the numbers are. Here's another set of parentheses, 2 times $4.95. Can I solve that? Sure. So let's move to scrap paper. Write the number with the most digits on top, which will be $4.95, times 2, because that's the fastest way to multiply. Multiply, divide decimals means must dance decimals. So there's Decimal Dan. Let's dance him out 1, 2 places, write him down, and put that table around him. And we go ahead and multiply. We get 990, and we have to dance Decimal Dan back in 1, 2 places. So that parentheses equaled $9.90. And I'll write it down right underneath those parentheses. So I've solved for all the parentheses that I could solve for. I'll bring everything else back down. So I'm going to say open parentheses 3 times P, which I couldn't solve for because I don't know what P is, plus, I already have the amount that that parentheses is worth, plus $1.22 minus $0.50 equals $15.99. So I have now solved my SUS step. I look on the top right hand side at my work backward steps. I've already solved the SUS step. I'm up to my purple WB step, which stands for work backward. So I'll write down WB to show that I'm on the work backward step. And the work backward underneath it says opposite direction and opposite operation. So I find my very end, remember because I'm working backward, I go to the end. I have $15.99, so since I'm moving backwards, I'll write that first, $15.99. Cross it out since I've used it. Next I get to the equal sign, and that's the only part that stays where it is. So directly where it was, I move it down and write the equal sign. I've used my equal sign. In front of that I have a minus $0.50. Opposite direction, opposite operation. So what's the opposite of subtract? Add. So I will add $0.50. And cross that out since I've used it. Next I have plus $1.22. What's the opposite of plus? Minus. So I'm going to say minus $1.22. I used it, so I cross it out. Keep working backward. I have plus $9.90. The opposite operation would be minus $9.90. I used it, so I'll cross it out. Next I get to my variable, which is my letter, my unknown, my P. And I'm going to underline that twice, which reminds me that my unknown goes after my equal sign. So the opposite of 3 times P, if I worked backward, would be P divided by, right, opposite of multiplication is division, P divided by 3. I've used that, so I cross it out. So I've now done my work backward step. I've crossed everything out, which means I didn't miss any step. My next step, if I look on the top right-hand side, is my green S step, and S stands for solve. So I'm going to solve to find the unknown amount. When I get to solve, I just do my work backward step exactly as I see it. So I see $15.99 plus $0.50. Add, subtract decimals, always straight decimals. So I'm going to line up my decimals, and now I can add. I cross out $15.99 since I wrote that down. I cross out plus 50 cents since I wrote that down. I go ahead and find my total. Don't forget to bring down my decimal as I get to it. So I have $16.49. The next step is minus $1.22. Again, add, subtract decimals, always straight decimals. So I line up my decimals, Cross out my minus 122 since I've used it, and go ahead and do the math. 1 take away 2 is 7, 4 take away 2 is 2. Bring down my decimal, 6 take away 1 is 5, 1 take away nothing is 1. I have another step that says minus $9.90. Line up my decimals, add, subtract decimals, always straight decimals. I used it, so I'll cross it out, and I'll do the math. 7 take away 0 is 7, 2 take away 9 can't do it, so I cross out the 5, make it a 4. This becomes a 12. 12 take away 9 is 3. Bring down my decimal. 4 take away 9 can't do it, so I cross out the 1, make it a 0. This becomes a 14. 14 take away 9 is 5. I have $5.37. I have now solved everything before the equal sign. So that means that that P equals $5.37. So what do I need to do? I need to take that P and divide it by 3. So I'm going to take $5.37 and divide it by 3. That will get me my final answer. I've run out of room on this page, so I'm going to move to some scrap paper to do that division problem. So I have $5.37 divided by 3. First step, does Mrs. Wainwright savor chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. I see that this problem has Betty in the house, so I cannot have a remainder. I'll put the decimal inside the box to remind me of that. I know when Betty's in the house, Dan is not there, so she's just dancing. She's going to go right up to her attic, so I move her up and out of the problem. This is a money problem. There's only $1 sign, so it stays and has to move up into my final answer. Let's focus on the 5. Is 5 greater than or equal to 3? Yes. So that's my first chocolate bar, and every digit after that gets a chocolate bar. Now we're ready to divide. I'm going to go through my 3 times tables till I get to a number larger than 5. 3, 6, up too high, put 1 finger down. My answer is 1, and that's divide. Multiply. 1 times 3 equals 3. Subtract. 5 take away 3 equals 2. Compare. Is 2 less than 3? Yes. Bring down. Is there anything to bring down? Yes, I have a 3. If I bring down, I have to go back and divide. So I'm going to go through my 3 times tables till I get to a number larger than 23. 3, 6, 9, 12, 15, 18, 21, 24. Stop. Put 1 finger down. My answer is 7. Multiply 7 times 3 equals 21. Subtract. 23 minus 21 equals 2. Compare. Is 2 less than 3? Yes, it is. Bring down. Is there anything to bring down? Yes, use an arrow to bring down the 7. And if I bring down, I go back and divide. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Up too high, put 1 finger down. My answer is 9. Multiply 9 times 3 equals 27. Subtract 27 minus 27 equals 0. Compare. Is 0 less than 3? Yes. Is there anything to bring down? No. Is there a remainder? No, there's not a remainder, which is good. So my answer is $1.79, but this is a word problem, so I need to go back to my original problem and see what my sentence will be. My question says, how much did each pen cost? So my final answer sentence will be, each pen cost $1.79, and that's my final answer. Please stop the video and complete worksheet number 1 right now. Let's take a look at question number 2. Last week, Vivian spent a total of $20. She spent $9.95 for tickets to the school fair, $5.95 for food, and the rest for 2 rings that were on sale at the school fair. If each ring had the same cost, how much did each ring cost? When I'm given a total amount, in this case $20, which is the total that she spent, and I have various things that happened, things that I bought, things that I saved money on, etc., I know that this is a setup for the work backward strategy. Work backward has 3 steps, as I see on the top right hand side. My first step is my SUS step. Final question asks, how much did each ring cost? So I'll set up for my SUS, label your steps as you go. Remember, the SU stands for setup. We have the unknown. equals the total at the end and everything else in between. How do I know what the unknown is? The question tells me. How much did each ring cost? So the ring is the unknown. Look back at the question and see if it tells you anything else about a ring or rings. Well, she spent $20, $9.95 for tickets to the fair, $5.95 for food, and the rest for 2 rings. Oh, it tells me right here that she bought 2 rings. So I'm going to say 2 times R, because I don't know how much the rings cost. That's what they want me to find out. Or make sense that it stands for rings. Since I used the rings, I'll cross out the 2 rings. The next thing I need to find to put at the very end is the total. And it says last week Vivian spent a total of $20. So I'll go to the very end, write equals $20. And I'll cross that out since I've written my total. So I started with my unknown, I have the total after the equal sign, and now I have to go back to everything else. Well, it says she spent $9.95 for tickets to the school fair, and if she spent $9.95 for tickets, that's money that she had to put, which was towards that $20, so we know she bought 2 rings, and she bought the tickets for $9.95. Let's cross out the $9.95. What else do we know that Vivian did? Well, we also know that she spent $5.95 for food. So she spent another $5.95 toward that $20 total. Let's cross out the $5.95. What else did Vivian do? Doesn't look like she did anything else. I've crossed all of my numbers out of my problem. So this is now my SUS step. I've solved the setup. My next step is the S in parentheses, solve the parentheses. The only parentheses I see here have the variable or the unknown letter, so I can't solve it with the unknown. There are no other parentheses in this problem, so I'm now done with my SUS step, and I'm ready for the next step, which is WB, which stands for work backward. Remember, work backward is the opposite direction and the opposite operation. So go to the end and take my $20. I'll start with it here, cross it out. Take my equal sign. It stays exactly where it was. I'm done with the equal sign. Move on to plus $5.95. What's the opposite of that? Minus $5.95. Cross it out. Move on to plus $9.95. The opposite would be minus $9.95. Cross it out. Now I move to the next section, which has my variable, and as soon as I see my variable letter, I underline it twice to remind me that this goes after the equal sign. So it says 2 times R. The opposite of that would be R. Opposite of times is divided by 2. And now my work backward is set up. I'm ready for my next step, which is the S, or the solve step. I need to solve the work backward to find the unknown amount. Okay, let's do that. So I see $20 minus $5.95. Add, subtract decimals, always straight decimals. Cross out my 20 and my minus $5.95 since I used them. I'll go ahead and do the math, but I cannot subtract, so I need to borrow. Cross out the 2, make it a 1. This becomes 10, but I still can't subtract. So borrow from the 10, cross it out, make it a 9. This becomes a 1, but I still can't subtract. So borrow from this 10, cross it out, make it a 9. This becomes a 1, and now I can subtract. 10 minus 5 is 5. 9 minus 9 is 0. Bring down my decimal. 9 minus 5 is 4. 1 minus nothing is 1. So I have $14.05. Now I have a minus $9.95. Again, add, subtract decimals, always straight decimals. Cross it out since I wrote it down, and let's go ahead and do the math. So there's $4.10. I've solved everything before the equal sign, so I know that $4.10 is going to be equal to R, but I know we have to take the R and divide it by 2. So I have to take $4.10 and divide it by 2. Let's move to some scrap paper to solve this part of the problem. So I'm going to write my division box, $4.10 divided by 2. Steps for long division. Does Mrs. Wainwright savor chocolate bars regularly? Certainly. Underline the B, arrow from the B to the D. I see that Betty is in her house, so next to the remainder I have to put Betty in her house to remind myself that I cannot have a remainder. Decimal Dan is not there, so Betty is simply going to move up into her attic and practice her dancing. There's $1 sign, which means it stays in my answer. I move it up so I don't forget. Okay, so let's focus on our first digit in the dividend, 4. Is 4 greater than or equal to 2? Yes. That's my first chocolate bar, and every digit after that gets a chocolate bar. Now I'm ready to go ahead and divide. My answer is 2. Multiply 2 times 2 equals 4. Subtract 4 take away 4 is 0. Compare, is 0 less than 2? Yes it is, that's good. Is there anything to bring down? Use my arrow to bring down my 1. When I bring down, I have to go back and divide. The answer is 0. Remember, 0 is a digit that you can put on a chocolate bar if necessary. Multiply 0 times 2 equals 0. Subtract 1 take away 0 equals 1. Compare, is 1 less than 2? Yes, that's good. Anything to bring down? Bring down the 0. If I bring down, I go back and divide. The answer is 5. Multiply 5 times 2 equals 10. Subtract 10 minus 10 equals 0. Compare, is 0 less than 2? Yes, it is. Is there anything to bring down? No. Is there a remainder? Nope, 0 is not a remainder. That's good. So, nothing to bring down. My answer is $2.05. But this was a word problem, so I need to go back to my original problem to see what my sentence and unit will be. And the question says, how much did each ring cost? So the answer will be, each ring cost $2.05, and that's my final answer. Please stop the video and complete worksheet number 2 right now. So to review, and I suggest you go back to this screen whenever necessary, the work backward has 3 steps. SUS, which is set up and solve parentheses. So first we write the unknown, at the end we write equals the total, and everything else goes in between. Then we solve the parentheses if possible. Our next step is the WB step, the work backward, so we go the opposite direction and the opposite operation. After that, we solve to find the unknown amount to get our final answer. So in this problem, my unknown was the cost of each pen, so I used a P. It said that there were 3 pens, so I had to multiply that times 3. That was my unknown. I went to the end and found the total, and it said the total spent was $15.99. Then I went back through the problem to find all other things that were done and wrote them down. When I was finished with that, I found any parentheses that I could solve. I could not solve 3 times P because I had an unknown in it, but I was able to solve 2 times 495, which I did, and wrote it down, and I brought everything else down underneath that. At that point, I had finished my SUS step. I moved to my work backward. Remember, I started with my $5.99. The equal sign always stays directly where it was, and I did the opposite operation. So instead of minus 50 cents, I said plus 50 cents. Instead of plus 122, I said minus 122, and so on and so forth. Once I finished my work backward, I solved it in order. So I had my $15.99 plus 50 cents, and then I subtracted my $1.22. I subtracted my $9.90, which gave me $5.37, and once I finish everything in front of the equal sign, that tells me what the variable equals, but in this case I then needed to divide that by 3, because we didn't just have 1 ring, we had 3 rings. I moved to the scrap paper, I did the division, followed my steps to get my final answer. We will do much more practice of this together in class. If you have any questions or concerns, please do not hesitate to see a teacher so that we can sit down and help you with this. The goal is that you should confidently be able to say, I can use a strategy work backward to solve multi-step decimal problems. Good luck with this lesson.